Welcome to today's webinar, Do You Turf, an Optimization Approach, hosted by your friends at Sawtooth Software. I'm Megan Pites, the Ingenuity Ambassador at Sawtooth Software, and I'm joined by Brian McEwen, our Director of Client Services. Turf is such an easy technique to implement and can be used with all different types of data, rating, rankings, and even MaxDiff questions. We look forward to sharing with you our experience with Turf. So let's get started.
Okay, so today we are talking about Turf. And so our roadmap for the day is going to be talking about just what's the idea, where did it come from. We're going to talk a little bit about gathering Turf data. I'm going to show you an example specific to MaxDiff data, which is not something typically associated with Turf analysis. We'll show you how you can do some things in our MaxDiff Analyzer tool. And then Megan's going to finish off and kind of talk about a little bit more in depth the idea of reach versus overlap and show you some neat things that you can do that kind of go even beyond Turf. So Turf stands for Total Unduplicated Reach and Frequency, which is a pretty big, long name there. The general idea behind it, though, is really in the word reach, is that we are kind of thinking about our data a little differently. It's very common for us to ask people to rate and rank things and to calculate average scores and just kind of pick things that do well. What Turf does is just kind of changes our view of things, where we are viewing a successful product as something that reaches someone. And there's lots of different ways you can define reach, and we'll talk about some different examples and things. But an example situation might be like the bottom paragraph we have here. If we can only offer 3 flavors of ice cream, maybe on the shelf, or we can only produce 3 in our facilities or something like that, we're trying to answer the question, which 3 should we offer to do the best job? And in this case, we're thinking, so that it reaches the greatest number of people, so that they have at least one flavor that they like. And rating or ranking, we're categorizing someone as being reached if their favorite flavor is in the mix of 3. And so Turf actually came out of media research as a way to try to help maximize your reach while minimizing the amount of money that you're spending on print advertisements or television ads or things like that. So an example problem would be, you're an advertising agency and you're trying to figure out which TV shows you should purchase some ad spots in. And if TV show X has an audience of 1 million and another TV show Y has an audience of 1 or 2 million, it's essentially dangerous to assume that you can just add those 2 things together and you're paying for 3 million unique sets of eyeballs on your ad. Another example would be print magazine. You might want to put an advertisement in, say, Martha Stewart Living, and then another advertisement in Better Homes and Gardens. You might have a whole lot of overlap there in people that subscribe to both magazines. And so you might want to choose instead to spend your money on something radically different, like Guns and Ammo magazine or Hunters Monthly or something like that, to maximize the number of unique people who are seeing your ad. So the applications are situations where you're trying to come up with a mix of things. You're trying to figure out configuration options, flavors, adding to new existing product lines to reach a greater number of people, or in advertising, which mediums overall, or which specific shows or magazines, and essentially trying to get to this idea of satisfying the most number of people with the fewest number of products and services. That's what we're trying to do with Turf analysis. So as an simple example, let's just say we were going to have 3 potential ice cream flavors, vanilla, chocolate, and mango. But for some reason, we only want to produce, or we only have shelf space for 2 of those. A traditional approach to this might be to do some type of rating scale question, maybe like a 5-point scale, something like strongly would like to strongly dislike, or would purchase, would not purchase, something like that. And to illustrate the benefits of TERF, what we did is we made 2 data sets that kind of look similar but are actually made up of different people. So data set 1, what we did is just in Excel, we made 75 respondents who rate vanilla a 5, chocolate a 4, and mango a 1. So they kind of just like these traditional flavors. And then we have 25 respondents who rate vanilla and chocolate a 1, but mango a 5. They're this kind of niche group that really like this strange, different flavor. And then we kind of did the same thing, another set of 100 respondents, but this time we don't have overlap happening. So 50 of the people just like vanilla, 30 of the people just like chocolate, and 20 of the people just like mango. And so what happens is if you simply summarize this data, data set 1 that has the overlap, you get this picture that vanilla is the most preferred brand, or most preferred flavor, chocolate is the second most preferred, mango is in third place. And you get kind of the same answer with data set 2 that doesn't have the overlap, that vanilla is the most preferred, chocolate is second, mango is third. So in both cases, the data would support producing vanilla and chocolate. We're not saying that that's necessarily a wrong answer, but what TERF does is allows us to look at things a little differently, and instead of just doing something like average score, think about things in terms of reach, and also we're going to talk about frequency as well. So to show an example of kind of what's going on under the hood, what we would do is we'll take our first response here, and so this is the person that likes vanilla, likes chocolate, doesn't like mango. And so the reach for this person, they would be reached by vanilla, so we have a 1 in that column. They would be reached by chocolate, so there's a 1 there. And they would not be reached by mango since it's something they don't like, so we'd put a 0 in there. So running this through a TERF algorithm, if we were to say, let's look at 2 flavor bundles, what would happen is the vanilla and chocolate, we would reach this respondent, so we get a 1 in the reach column. However, both options reach them, so we get a frequency of 2. And frequency is kind of a secondary measure here, where if we have options that reach the same number of people, bundles that will reach the person with multiple items in the bundle should be considered better solutions. So that's why you get a frequency of 2 in the first row. Chocolate and mango, in this case, the second row, this would reach the person with the chocolate offering, and the frequency drops from 2 to a 1. And then vanilla and mango still reaches this person, again, with a frequency of 1. So if we add then respondent 2, who is one of our mango-only people, then we get the following counts up in the green table. So again, respondent 1 reached by vanilla and chocolate, respondent 2 reached by mango. Now down in our overall reach and frequency table, we can see that vanilla and chocolate is actually the suboptimal solution when considering reach, because it only reaches respondent 1 and not respondent 2. But it does have a frequency of 2. So we're going to focus on reach with frequency being a secondary goal. And so in this case, the chocolate and mango or the vanilla and mango actually come out to be the, quote, preferred bundle in this case, because we're reaching both of these respondents with one of the offerings in there. So that gives you kind of an idea of what we're doing under the hood when we're calculating reach and frequency for people. So how do you get this type of TERF data? Well, there's a lot of sources that it can come from. Multi-select questions, you can ask someone, which colors would you like your widget to be? And so anything that is checked gives you that inherently binary data of reach, not reach. A lot of people will do ranking questions, and then you'll do something like a top 2 box or the top box or something like that. You essentially turn it into binary data if someone is reached or not. So that can be used for both ranking and rating things. Counts data, you can ask people about, how many would you consider purchasing, and if the number is anything greater than 0, that would be, again, a 1 in our reached column. So there's a lot of sources for things. And then one of the things that we at Sawtooth have done is have thought about ways to incorporate this idea of reach with MaxDiff data. And so if you're not familiar with MaxDiff, as a reminder, maximum difference scaling, which is also known as best-worst scaling, is used for measuring importance or agreement or benefits when you have a list of items. And typically we'll use MaxDiff once we get larger lists of things. We often see it used once you start getting 5, 6, 7 items. It's kind of that threshold point where doing traditional rating or ranking questions starts to get kind of difficult for things. So an example that we might do for our respondents is we might have a big list of ice cream flavors and ask people what's the most and least appealing on there. And then, so we might have, 10, 15, 20 different flavors. We're going to show them a subset of flavors every time and ask them what the most appealing and least appealing is. And the software comes up with nice, balanced, uncorrelated experimental designs. And we can use a method like HB or latent class to come up with utility scores for things. And so MaxDiff is a totally awesome methodology for dealing with large lists of things. However, it's not the best thing to be used for turf analysis because these scores that come out, these utility scores, are continuous. So similar to some of like the rating and ranking data, we're going to have to discretify things. And so what we've done in our MaxDiff analyzer is come up with different ways to try to discretify things so that it fits within the turf framework. And so we're going to talk about these 3 different approaches here, where we're going to discretify by using a first choice rule, by using a threshold point, and then we're going to kind of depart a little bit more even from true turf analysis by trying to weight and score a bundle, kind of give it a strength measure, and then choose bundles that are really strong for the respondents. So I like seeing numeric examples, so these are the slides that help me the most. So assuming we've had, again, our same 2 respondents, respondent 1 likes vanilla, likes chocolate a little less, isn't really into mango. Respondent 2 doesn't really like vanilla, doesn't really like chocolate all that much, but really likes mango. So we might come up with some utility scores like this. And so the first choice criteria, what it does is says someone is reached if their top item is in the bundle. So in this case, it's vanilla for 1 and mango for respondent 2. That's our categorization of whether or not you're reached. So down at the bottom, the blue table, vanilla and chocolate, again, that only reaches the first respondent. Chocolate and mango only reaches the second respondent, but vanilla and mango reach both respondents. Okay, so that's first choice. Very simple, very much like a first choice market simulator if you're familiar with conjoint analysis, where people choose or people are reached by their top item. Okay, now threshold, what threshold does is says that someone is reached if a score of an item exceeds some amount. Okay, and so in this case, we're going to put the threshold at 0, and we're going to talk about, in the next slide, I'll show you why we would set it to 0. But you could set it to anything that you wanted. And we get similar output here where vanilla and chocolate, again, only reaches the first person, chocolate mango reaches the second, and vanilla and mango reaches both respondents with the threshold of 0. Now this is actually using one of a rescaling technique inside the MaxDiff analyzer, and I'm not going to get into the math about that right now, but the place where we recommend to use threshold is where you're doing anchored MaxDiff. And this is the idea that MaxDiff is inherently relative in its scoring of items. So if you hate all ice cream flavors, you could, in theory, come up with the same scores as someone who loves all ice cream flavors if you happen to choose the same ones, right? The ice cream flavor you hate the least is the same as the one that is loved the most by the person who loves ice cream. So anchored MaxDiff, and we have a whole paper on this, so we're not going to spend too much time in the workshop, but or in the webinar. The idea behind anchored MaxDiff is to ask an additional question to kind of draw a line in the sand across that is a unique point across all respondents. So The indirect approach is what I have up on here on the screen, where we add a question below each MaxDiff task, and we introduce some sort of concrete thing like appeal, or I would purchase, or I would recommend to someone, I would buy a pint off the shelf, or something like that. And the person responds with, you know, none of these are good, some of these are good, and all of these are good. And what that does is it essentially adds an extra item to the MaxDiff design that we constrain to be 0, and that way anything with a positive score, person in this case would say, yes, this is appealing to me. And so it's a really neat way of anchoring all the scores to some concrete point across all respondents. And then in TURF, we're kind of doing a really robust application of TURF, where we're saying someone is reached if they answered yes to this follow-up anchoring question. I would buy it. It is appealing to me. So this is an example of the indirect way of doing it. And then you can also do it in a direct approach, where you ask it kind of separately from the MaxDiff exercise, either before or after. In this case, we're going to show check boxes and just say, you know, which of these do you find appealing? Just check the boxes there. And all this is handled automatically in the software. The direct approach, you have to set it up just a little bit more, but everything is basically handled. The software runs the analysis, and it dumps out these scores that now have a concrete anchor on the 0 and are really great for use with the threshold method of the MaxDiff analyzer for coming up with bundles of items. The last method we're going to talk about is weighted by probability. And so this one's a little mathier, but I'll try to kind of explain what's going on here. So the first bullet point we have here, this is one of the ways where we try to give each item a strength score. So if you're familiar with conjoint, this kind of looks like a share of preference formula, where we're taking the utility of item I, we're exponentiating it, and then we're dividing it by the sum of things in a choice task, also exponentiated. Now what's different than a conjoint here is that we're trying to say, what's the strength of this item if it was asked in kind of a representative task? So if I showed 4 items in my MaxDiff questions, then an average item in a MaxDiff, again, is that 0 point. And so e to the 0 is 1, and so we just put in the number of items in the spot for A there. So we're essentially calculating what's the probability of choice of item I in kind of a task where it's just against a bunch of other average items. So it's kind of a little weird to think about the first time you hear it, but this idea of kind of calculating strength of the item. And so we take that formula, and the second bullet point we have here is basically saying, well, what's the strength of item I and item J? And so we expand out that formula and saying, well, item I, the strength of item I and item J are equal to this formula where we throw the e to the ui plus e to the uj, and if we simplify that down, that's what gets us to the third row there. So we're kind of saying, what's the strength of putting item I and item J together in a, quote, representative average MaxDiff task? So if that doesn't make sense and you want to talk about that more, we'd be more than happy to follow up with you. But that's essentially the math of what we're doing. And so what's neat about the weighted by probability is that it is a little bit more departure from TURF, so we're not explicitly saying people are reached or not reached. But what's cool about it is we get this, the outcome of that formula gives us this number that here I'm calling strength, where we can now see that vanilla and mango is a stronger combination than chocolate and mango. And if I back up in my slides a little bit here, we can see that in things like the threshold, and so first choice gives us the the quote correct answer that vanilla and mango is the best one, but we might have some overlapping items if we had a much larger set. Threshold, we essentially get a tie between the chocolate and vanilla combination with mango, but the weighted by probability, because vanilla is much more preferred than chocolate to the first respondent, we get this strength score coming out of here that shows us that vanilla and mango is really the best option for these two respondents. So I'm just going to show you a quick little demo now. Pull this over here. So this is the MaxDiff analyzer. What I've done here is I've taken our sample MaxDiff study. This is an interesting little study about re-enlistment benefits for the Navy. So considering people who are ready to re-enlist and offering them potentially a bunch of different benefits if they re-enlist for another term. And so there's some nice little things that the MaxDiff analyzer does. The scores tab allows you to do segmenting and weighting. So if I turn on my gender variable, it splits out by male and female, and I can look for differences in the scores. And if you're, again, familiar with conjoint and the idea of a choice simulator, we can do that as well. So if we wanted to see, who would choose between a 3-year obligation and a $2,500 re-enlistment bonus, we can compute that and we can use the scores and say, about 59% I would predict would choose item 1 and about 41% would choose item 18. So both of those things are pretty neat, but the turf is where I think this tool is really neat. And so what we can do is set the number of items in our portfolio. So maybe we're looking for the 3 best enlistment benefits we could offer people. And then you can pull between those 3 options we chose, first choice, threshold, and weighted by probability. You can also do filtering if you want to just look at one category of people at a time, and you can do weighting and things like that. You can restrict your search space a little bit, so you can choose items that cannot occur together. So, it wouldn't make sense to offer the $2,500 cash bonus and the $5,000 cash bonus and the $10,000 in the same bundle. So we could set up prohibitions here if we wanted. And you can also force specific items into each portfolio. So if there was something that required these 2 things to be offered in tandem, you can do that as well. But what it does is it just runs and says, all right, in this case, items 5, 19, and 20. In that case, we reach 154 out of our 250 respondents we have. And so that is a reach of 61.6%. And you can also evaluate, by default, we dump out the 100 best solutions. You can increase that if you want and look at even more solutions. And you can download both the summary or download the individual results if you wanted to do maybe something on your own in Excel or SPSS, SAS, something like that. So the MaxDiff Analyzer is a fun little tool for kind of taking your MaxDiff data just a little further, running some predictions, some simulations, some turf optimizations, and that's that.
Brian, I'll jump in really quick. One thing about the pre-selected items in the portfolio, a lot of times that's helpful if a client already has certain features on the marketplace. So if we're thinking about the ice cream example, if chocolate and vanilla are already out on the shelf, they need to figure out which complements those 2 flavors best, right? So we would force chocolate and vanilla to be in the set, and then we would figure out which of the additional flavors provide the most reach. So it's really helpful when you're testing things that already exist and then can also implement them on the back end for analysis.
Yeah, it definitely saves you a bunch of time than dumping out, 500 solutions and searching for all the chocolate and vanilla ones out there. So yeah, great point. All right, and then the last thing that I just wanted to show before I turn it back over to Megan is, potentially one way that turf data, the output of this analysis is reported back to people. A lot of times we will build a chart like this where, we'll start with the best option that reaches the greatest number of people, and again, maybe that's chocolate in this case, and then start to give an idea of the incremental value of adding each one of these things. And this can kind of be helpful to help you visualize, is it actually worth, maybe once I get to strawberry, is it really worth adding the additional options on there? And turf should not be used in a vacuum. I'm going to turn it over to Megan before I start down that path, because she's going to talk about some of the limitations of turf.
Thanks, Brian. I'm just going to share my screen, and let's see. Now, do you see it looking nice?
Yep.
Okay, perfect. Okay, exactly. So some of the limitations. Now, I'm a practitioner by nature, but I'm also a mathematician. So there are certain things that I tend to think about when it comes to limitations of turf analysis. And one of those is when we talk about this frequency interpretation, oftentimes it's somewhat misleading, right? If we remember back to a couple of the slides, we assumed that someone who wanted, who liked chocolate and vanilla had a frequency of 2 when the item set was chocolate and vanilla. But that doesn't necessarily mean that when they go to the store, they're always buying chocolate and vanilla together, right? It just means that maybe they buy one or the other or both. And so what I like to do when I'm talking about fast-moving consumer goods or things where there's an actual frequency to your purchases, I typically like to add weights to my data based on those volumes so that I can make that frequency interpretation a little bit more strategic and value add. An example would be that someone who's going to purchase 2 times a week is a lot more valuable than someone who's only going to purchase once a month. And so my data should actually reflect that, right? I should be more concerned about the decision to the person who's going to be purchasing most often. So that's one thing to think about. And you can also, if you take the simulator out of our MaxDiff analyzer, you can even adjust those frequency numbers to be looking at actual counts instead of just looking at preferences. The second thing to think about is that our rules to create reach in the MaxDiff analyzer and oftentimes any turf simulator assumes that the respondent is going to be satisfied with one specific product and is not going to seek variety. So the thought process there being that if I offer vanilla and you told me you liked vanilla, then I'm going to be just fine, and every single time you go to the store, you're going to buy vanilla. But we don't know that we know that that's not necessarily the case, right? Sometimes we just get that craving for a mint chocolate chip. So you'll want to be wary of using just turf data when it comes to some of these fast-moving consumer good categories or other categories where there's a lot of variety seeking. So this is when you really want to learn about your client, their objective, and their product. Which kind of leads to my third point as well, is that consumer segments really aren't defined by just one offering, right? If we think about how many credit cards there are out there, and many of us probably have more than one in our wallet. And the reason why we do that is because one credit card doesn't fit every single situation, right? Some people really like to get rewards on their credit cards, so they don't care about the credit limit. They don't care about the interest rate because they're paying it down. They want the 5 times rewards on travel and dining, where somebody else is using it to kind of get them through the rest of the week until the paycheck comes. So maybe they do care about interest rate, or they do care about credit limit and things like that. So we have multiple credit cards for multiple needs. Same with the ice cream example. One flavor doesn't appeal to every single occasion. And so we need to make sure that the entire product line when we're referring to ice cream or consumer goods is strong, or the products that we're offering, in the example of the credit cards, appeals to the majority. And that brings us to this topic of overlap. So as Brian mentioned in one of the first few slides, we kind of have this objective that we're answering when we think about turf or reach, right? If we can only offer 3 flavors of ice cream on the shelf, which 3 should we offer so that as many people as possible have at least one flavor that they like? So that's what turf is going to give us. But what if one of our strongest flavors is sold out, we don't want people to walk away from the shelf. We need to have a substitute for that item or an item that overlaps. So if we can only put 2 items on the shelf and we choose vanilla because it was the strongest, and then we chose mango because it reached the more niche group of people. If we didn't have vanilla on the shelf because it was sold out, think about how many people would walk away because mango doesn't appeal to them at all. So what I like to consider is looking at what's called association rules. And these are if-then statements that help uncover relationships between what is usually seemingly unrelated data. So the example here is if we're at a grocery store and a customer buys a dozen eggs, we can learn from their transactional data that he is also 80% likely to purchase milk. And if we knew that these things go together in tandem, we would know that maybe we could put promotions on if you buy a dozen eggs, you can get, half off of your milk gallon or things like that, and encourage those types of combinatorial purchases. So what I use to do this is what's called the A rules package in R. So if any of you are familiar with R, it's an open source software, so quote unquote free, which is really exciting. But it does do a lot of supplemental algorithms and statistical analyses that Sawtooth software doesn't provide. So I usually like to use it in tandem with our software. And in the A rules package, we get a couple of different measures to help us indicate if there are these combinatorial things that should be combined. So if you can see down on the bottom right, we have this example of items that are typically in people's carts when they go to the grocery store. So if we just looked at counts, the number of items that people purchase, it looks like 3 people are purchasing beer, 4 people are purchasing bread, 2 people are purchasing cola, 4 people are purchasing diapers, milk, etc. This could be people, or it could be the amount of items in your cart. We'll just refer to them as people for now. But you can see if we only had this one item set information, we might say, okay, bread, diapers, and milk are where we're really getting the most bang for our buck, so let's not worry about that. Those things there's no relationship there. But if we start to look at these 2 item sets, we can see that when we put things together, there are 2 people who are buying beer and bread together, 3 people who are buying beer and diapers together, oddly enough, 3 people who are buying bread and diapers, and so on and so forth. And then we want to go even further with that and figure out are there any item sets that are, more than 2 items that people are typically buying together. And we can see in our 3 item set combination that people are buying bread, diapers, and milk together. So this is kind of illustrating those frequent item sets, so things that are bought in conjunction with each other versus when we think about reach, right? We're capturing the people who buy the bread, and then we want to reach a completely different group of people. So maybe those are the people that buy the diapers or the cola or something else. So we're getting completely different recommendations whether we look at reach versus overlap. And I'll just go over the 2 outputs from that A rules package, which I'll show you in a minute, that I like to look at are support, which indicates how frequently the item appears in the database. And then the next one is confidence, which is the number of times the if-then statement has been found to be true. So if we take a quick look at the output here, we can see that the combination of milk, bread, and butter together has a support of 0.2, meaning that this combination occurs in 20% of all the transactions in the store. And then we have our if-then statement. So if someone buys butter and bread, what is the likelihood that they're going to buy milk? And our confidence number there is 100%. So for 100% of the transactions containing butter and bread, milk is also bought. So that's pretty informative information. Hopefully you're starting to see how this can be tied to turf analysis as well, or in addition to turf. And then we also get a measure called lift, and that's going to tell us the probability of the occurrence of the antecedent and that of the consequence. So what is before the if statement and then the consequent, the then statement, if they're independent of each other. So if we have a lift of 1, then that means that really no rules can be drawn. They're kind of independent. They're not really functioning in conjunction. But if the lift is greater than 1, then that lets us know to the degree that those two things actually are dependent on each other. So if we start to think about ice cream example again, maybe we can start to see that the people, if they like vanilla, they also like butter pecan or something very similar. If they like chocolate, they also like Rocky Road. So you can start to see maybe I should be including Rocky Road with my chocolate offering in case the chocolate is not on the shelf, instead of going with a completely niche idea of a mango option that's really only going to get me a subset of consumers that there's no overlap with. So if you go to this website here, Our Data Mining, they have a lot of great examples, but this actually takes you through an example of data from the Titanic. And what we're looking at here are things that the way that each of the Titanic attendees were classified, right? You have the classes that they were in, first, second, or third. You have the sex of the person, whether they're male or female, and you also have the age of the person, whether they're a child or an adult. So what we were looking for here on the left-hand side is to see, are there any combinations that, essentially implied survival or not? And you can see the first 4 combinations are looking at survival. So anybody on the left-hand side, if they were a child in the second class, we're trying to find out what is the likelihood that they survived. So remember, support is going to tell us the proportion of people in this data set that survived and were a child in the second class. So pretty small proportion of people, but the confidence is 1, meaning that 100% of the second class children survived. And that lift, which is greater than 1, is a 3, meaning it's a very, very strong relationship, and they are completely dependent on each other. Same with females in the first class. It's a small proportion of our total data set, right? Only about 6% of women in the first class survived. But there is this very high confidence in saying that if you are a female in first class, your odds of survival are, 97%. If we move down to the 5th or the 6th one, we can see that male adults in the second class make up about 7% of the sample that didn't survive, and 92% of them didn't survive, right? So if you were an adult male in the second class, unfortunately, you did not make it when the Titanic went down. So just really interesting information. I apply this again to turf analysis when I'm looking for things when I want to look for things that overlap to make my item set strong. But hopefully you can see other applications outside of that as well. For example, whenever I do a drag and drop question and I have people drag things into different categories, I will often use association rules for that as well to understand what's going on within each of the different buckets. Or to see if there's some sort of antecedent consequent relationship that's happening, if-then statements. Really valuable for the clients in the long run. So a little bit of a step away from turf, but hopefully you found some of that additional information helpful. And I think that is all that I have. Brian, did we have any questions that came in?
Yeah, there actually was one question about using the MaxDiff analyzer for non-MaxDiff data, and that actually is something that we support. When you're setting up a project, you choose from a drop-down box to say this was a MaxDiff project, this was an anchored MaxDiff project, or this is a generic project. And so if you choose that generic option, then you can import a CSV file of like your binary data, your checkboxes, 0 and 1s, or you could import that rating scale data, 1 to 5 scale, and then what it does is it kind of changes the view a little bit. It doesn't do the MaxDiff rescaling stuff, and it removes the weighted by probability option because it really doesn't make sense anymore, but it still lets you do the choice simulations, the weighting, the segmentation, and it lets you do both the first choice and the threshold method. So yeah, it's a little bit of a robust tool in that way, in that you can use it just for any of your general survey data as well. And then the second question we had was, is there any way to just see all possible solutions? And the answer to that is kind of yes and no. If your search space is pretty small, then you can just crank up that max number of solutions setting and tell it to produce all the possible solutions. But when your search space gets really, really big, like you were choosing 16 items out of 100 items, times where trying to do an exhaustive search would take a really, really long time. We actually switch algorithms where it's called surf and turf, where what it does is it tries to ride a wave of really good previous combinations. So in trying to get to the 16 item combination, instead of testing all possible 16 item combinations, it will look at 2 and 3 and 4 and 5 and kind of work its way up and ignore really bad combinations of things and just look at really good combinations to build itself up. So when your search space gets really, really big, we don't do exhaustive and you can't look at all possible combinations. You could try to get there essentially by using a combination of like the force these items to be in the solution setting. You could effectively say, I want to see the combinations that include item 1 and then include item 2, but it's not really going to get you to the same place because you're going to have some overlap on things there. So that's the answer to those questions. The other question we had was, can you discuss the impact of the recent change to the weighted by probability approach? So the recent change we did, the initial algorithm we used in the weighted by probability was basically that strength measure was basically saying, let's pretend like we were doing a choice task where we showed this one item, we put all the ice cream flavors in front of someone on a table, and we kind of said, what's the probability that someone would choose vanilla when presented with everything? And then we continue that on saying, okay, what's the probability that they would choose vanilla or chocolate when all the options were just sitting in front of them on a table? And kind of is that you really didn't ever get very much of a different answer than the other approaches, like the first choice, because when you put a bunch of strong individual things together and just kind of calculate it that way, what's the probability that they would choose A or B, you kind of always got the same answer. So what we're doing now is a little different, and it was come up with by Kenneth Fairchild, who is kind of our stats guy here, and he has graciously offered to walk anyone through the math of why this approach is better than what we were doing. It honestly goes a little bit above my head because it kind of goes in simulation math and some assumptions of the logit formula and how Gumbel error works, and so it's actually pretty complicated. But if you want to follow up, you can shoot us an email. The slide that Megan has up has our email addresses here, and we can put you in touch with Kenneth if you want to get more into the stats and the math of things.
Great, thanks, Brian. A couple of other things I'll mention that I typically get asked about when presenting TURF results is what's a good reach percentage? What is kind of like the minimum or the recommendation or the threshold? And of course, every time I answer like a statistician and say it depends, right? Because if depending on the approach that you use, whether it's first choice or threshold or weighted by probability, that's going to impact that reach percentage, as well as kind of what items you actually tested in the list. If you have one item that's like the clear outright winner and then everything else is kind of, minimal, then your reach is basically never going to get any higher even when adding some of those other items. So that reach could be really high initially, or that reach could start out pretty low. So there's really no threshold. What I would recommend internally is if you have turf data on topics or categories that are similar, you can kind of keep track of that over time and maybe give your clients recommendations. But as far as from a Sawtooth software standpoint, that reach percentage that you're looking for or that is a good thing really just depends on the items you're testing, even the number of items you've tested, and how you've defined reach. Same thing with the number of items in the set. You know, sometimes I have clients who only want 3 items. Sometimes they want 10 items out of 12. Obviously, as you add more items, you add essentially utility, so you always increase reach, but there comes a point where that increase is not statistically significant. So that's where you as a researcher or a practitioner comes in and tries to work with the client to make sure that, you know, adding this 6th flavor, and when we use ice cream examples, is it really worth it in terms of manufacturing costs to only reach an extra 2% of the population? If it's a really strong item or flavor that you would learn from some of that overlap analysis, then maybe it is worth it. But if it isn't, then maybe it isn't. And then as far as my preferred simulation method goes, I often find myself, I really like anchored MaxDiffs, so I often find myself doing an anchored MaxDiff and using the threshold approach when I have that kind of data. Or I am using some sort of other approach with data that's not MaxDiff. With the weighted by probability, it's an awesome approach and super mathy, so I love it, but it's sometimes hard to explain to the end client. So if you can come up with a way to visualize it and report it without having to dig into the nitty-gritty, like Brian was talking about, then weighted by probability is a really cool approach. But again, there's my it depends answer for all 3 of those questions. So I think that's about it, unless, Brian, you have anything else you wanted to add?
No, I mean, I think what you said is probably my opinion as well. The only other thing I'd note is from a software functionality perspective, if you run an anchored MaxDiff study, you can toggle on and off the anchoring data, whether or not it's included in the analysis. And so I know a lot of people will they'll run their scores without the anchor because a lot of their clients are used to seeing those rescaled scores that sum to 100. So we'll still provide that output to people, and then we'll run the anchored data, but rather than reporting the scores of that, they will use the anchored data in combination with turf analysis to maybe show the reach of the top few items when you calculate those from the average of the other scores. So you can do both, and just it's basically a checkbox setting in the settings of your utility estimation, whether or not you include that anchored stuff. So it's nice and flexible.
Great point. Thanks, Brian. And just so you know, if you don't have the MaxDiff analyzer already, that runs at about $500 for the year for a subscription to have 10 projects up there. And if you don't have MaxDiff yet, feel free to reach out to Brian or myself, and we can set you up with some of that stuff. So thank you for attending. We really enjoyed the webinar series and hope that you do too. And we look forward to seeing you next time. Thanks.